Hi guys, welcome to physics class. So I'm Subhashya. So today let us discuss the physics numerical section. Okay, these were the questions which appeared in our midterm paper, Bangalore North. So let us discuss all the 5 questions today. So these were the 5 questions which were asked. So from electrostatics and current, electricity and moving charges and magnetism. So the 42nd question was two charges were 9 nanocoulomb and 4 nanocoulomb. They are placed at A and C respectively of a right angle triangle in which B is 90 degree. Okay, so let us write what is given over here. So first always write given. So two charges are placed. Okay, so let me take Q1 as 9 nanocoulomb, Q2 is 4 nanocoulomb. Okay, so where we know that nano is 10 power minus 9 coulomb, and this is 4 into 10 power minus 9 coulomb. Okay, so they are placed at A and C respectively of the right angle triangle. So first let me take a right angle triangle over here. So this is 90 degree. So let me point this as B, this is A and this is C. So I have placed a charge Q1 at point A, Q2 at point C. Okay, and they've also given the distance AB is 3 centimeter. So AB is 3 centimeter, BC is 2 centimeter. So find the magnitude and direction of the resultant electric field at point B they are asking. So at the point B, we should find the resultant electric field. So as we know that these two are positive charges, so the electric field due to A, as it is a positive charge, it will be directed outwards. So let me name this as E1. And the electric field due to the charge Q2 is again it's a positive charge and it is directed outwards, and let me name it as E2. So resultant of E1 and E2 is taken as E. So now we are supposed to find what is the magnitude of E and the direction of E. Okay, so first let us find what is E1 and E2. So we know that the formula for E1 equals 1 by 4 pi epsilon naught cube by r square. Okay, so it's as it is even. So let me take it as Q1, and the distance r square I can be taken as AB square. Okay, so 1 by 4 pi epsilon naught, the value of 1 by 4 pi epsilon naught is 9 into 10 power 9, and the value of charge Q1 is how much? Q1 is 9 into 10 power minus 9. So divided by the distance is square, that is AB square. AB is 3 centimeter. So let me write it in centimeter in meters, that is 3 into 10 power minus 2 the whole square. So here you get it 9 into 10 power 9 into 9 into 10 power minus 9. So divided by 3 square is 9 into 10 power minus 2 square is minus 4. So now you can cancel 10 power 9 and 10 power minus 9. 9 can be cancelled. So you will get 9 into 10 power minus 4. If it goes up, it is plus 4. And SI unit of electric field is Newton per coulomb. Okay, so first I found what is E1. So similarly, find what is E2. Okay, as we know that E2 is along BC, E1 is along AB. Okay, so same formula, 1 by 4 pi epsilon naught Q2 by R square. Okay, so 1 by 4 pi epsilon naught value is 9 into 10 power 9, and the value of Q2 is how much? 4 into 10 power minus 9, and the distance r square is nothing but BC square. BC is 2 centimeter, so let me take it as 2 into 10 power minus 2 the whole square. Okay, so this can be written as 10 power 9 to 4, 10 power minus 9. So 2 square can be written as 4, 10 power minus 2 square is minus 4. Okay, so now you can cancel 10 power 9 minus 9. 4 can be cancelled. Yes, again you are getting 9 into 10 power minus 4 if it goes up, plus 4 Newton per coulomb. Okay, so you can see here E1 and E2 are equal. So let us now find out what is the resultant electric field. Okay, so the resultant electric field you have learnt in your grade 11 how to take the resultant vector. So E equals root of E1 square plus E2 square plus 2 E1 E2 cos theta. Okay, so now here you can see E1 E2 both are same, so you can just mention it over here. E1 and E2 are same, so let me take this as E1 square plus E2 as E1 square plus 2 E1 into E1. So cos theta, guys, what is the value of theta between E1 and E2? It's easily you can see here, it's just 90 degree. So directly you can write it as cos 90. Okay. So now what's the value now? Root of, so they both are same. So even square plus even square will be 2 even square. Okay. So plus, where cos 90, what's the value of cos 90? It is 0, right? So this complete term becomes 0. So you can just take E as, okay, so plus 0. So now root of 2 even square can be written as root 2 times root of even square is even. Okay, so we have a value of even, and the value of root 2 is 1.414 into the value of even is how much? 9 into 10 power 4. Okay, so it will be like 36. Okay, if you multiply, so you will get something around, yeah, 4936. Okay, on 12. Okay, so 12.726 into 10 power 4. The SI unit of electric field is Newton per Coulomb. So this is the magnitude of electric field. Okay, so the resultant electric field, and you can see the direction over here. So the direction as it bisects the two vectors, that is E1 and E2. So the direction of resultant electric field will be 45 degree. Okay, so the direction will be 45 degree. Okay, so this is just a very simple numerical. You'll have to just use the electric field formula, that's 1 by 4 pi epsilon naught q by r square. That's it. Okay, as both the values are same, so it is easy to calculate the resultant electric field. Okay, so I hope it's clear. Now moving to the next question, 43rd question. Okay, so they've given here ABCD is a side of square. Okay, so first let me draw a square. A, B, C, D, and three charges are placed at a point A, B, C. Okay, so I'll name the charges Q1, Q2, and Q3. Okay, so they are placed at a point A, B, and C. So Q1 equals minus 2 into 10 power minus 9 coulomb, whereas Q2 is 4 into 10 power minus 9 coulomb, and Q3 is 12 into 10 power minus 9 coulomb. Okay, they are placed at the corners A, B, C respectively. Okay, we are placed at A, B, C. Now let me calculate the work required to transfer a charge of 2 nanocoulomb from D to the center of the square. So to find the center of the square, I'll take a diagonal. Okay, so this will be the center of the square, and we'll name it as point O. So here we need to find out what is the amount of work done to move a charge from point D to point O. So we have a formula, work done formula, that's work done equals charge times the potential. So how much charge are we taking here? 2 nanocoulomb, 2, where nano stands for 10 power minus 9, and the potential difference between D and O. Okay, so I'll just take it as potential difference between D and O. Okay, so now let me find out what is the potential at point O and what is the potential at point D. Okay, so to find the potential at point O, first let us find out what is the distance over here. Okay, so the distance, they all are separated by a distance r. So the value of r is 0.2 meters. Okay, so now to find the potential at point O, which is given by the formula 1 by 4 pi epsilon naught q by r. So the potential at point O due to A is taken as q1 by, because the q1 I have placed at A, and the distance is OA. So similarly q2 by OB, and the next is q3 by OC. Okay. So the value of 1 by 4 pi epsilon naught is 9 into 10 power 9. Okay, so the value of Q1, Q2, Q3 we already have, but what's the value of OA here? OA or OB or OC? We have a value of R, but not the value of OA, right? So for that, what we'll do is we'll just take a value of AC. Okay, so value of AC from the right angle triangle, we know that AC square equals root of AB square plus BC square, that's R square plus R square, which is given as root of 2R square. So root 2 times R. Okay, so we get AC, AC as root 2 times, okay, AC equals root 2 times R. So now we have AC, but we need the value of OA, right? OA or OD or OB or what, OC or, right? So AC can be taken as, okay, OA can be taken as half of AC. So you can just take AC is root 2 by 2 times the value of R is 0.2. Okay, so the value of R is 0.2. So the value of this will be something around 0.1414. Okay, 0.1414 will be the value of OA, or it can be OB or OC. So all the three will have a value of 0.1414. So now let us substitute over here. So the value of Q1 is minus 2, 10 power minus 9, I'll take it common. Okay, so and OA, OB, OC, since both are all the three are same, will have a same denominator, that's 0.1414. So here the value of Q2 is 4, the value of Q3 is 12. So after solving, you get it something around 126 divided by 0.1414. As you can cancel 9, 10 power plus 9 and 10 power minus 9. So the value of V naught is 891.08 volt. Okay, so this is the value of V naught after after division. Now let me find out what is the value of VD. Okay, so let us use the same formula, 1 by 4 pi epsilon naught. Same thing, Q1 by the value of VD, the potential at D with respect to ABC can be, the distance can be taken as Q1 by the distance AD plus Q2. So Q2 is over here, the distances can be taken as BD. So Q3, the distance between 3 and Q3 and D is R, or ADCD. Okay, now let me substitute the value of 1 by 4 pi epsilon naught 9 as 9 into 10 power 9. So the value of Q1 is minus 2 divided by AD, distance AD is R. Okay, so plus Q2 is 4. The distance BD can be taken as AD, or the both are same. So it can be AC, which is nothing but equals to BD is equals to, you'll get root 2 times R. So I'll just take BD as root 2 times R, plus the value of Q3 is 12 divided by the distance CD is R. Okay, and then you can take 10 power minus 9 common over here. Okay, so now you can just substitute. So 10 power plus 9 and 10 power minus 9 can be taken common. So you will get something around 9. Just substitute minus 2 divided by the value of R is 0.2 plus take it together 12 by 0.2 plus 4 by root 2 times 0.2. Okay, so after substituting, you will get something around 9 into, okay, so you can just take 12 minus 2 is 10 by 0.2 plus 4 divided by root 2 times 0.2. So after solving, you will get something around 577.29 volt. Okay, so this is the value of VD and this is the value of V naught, and you can see here the value of V naught is more than VD. So here we are taking the work done formula, right? So in this case, what you can do here is, let me take a difference. Okay, so 2 into 10 power minus 9. So take a difference of VD and VIVO. So here VIVO is, you can just take 891.06, sorry, 08 minus the value of VD is 577.29. Okay, so when you take a difference, you will get the work done as 627.58 into 10 power minus 9 joules. Okay, so this will be the work done final answer. Okay, so I hope it's clear. Yeah, it's quite lengthy, but I think it's manageable if you know the formula for potential, mainly the potential formula. Okay, so now moving to the next concept, as you know that you have options, you have choices here, right? So you can choose any two numerical. I think you should like find out which is easier for you. Okay, so now we'll move to the next question. Yeah, as I said, this is a very simple numerical. Okay, so in case if you want to save your time or something, it's better you choose such simple numerical. Okay, so here we have, they've already given a EMF and internal resistance. So first let me write out what is given. Given E1 1.6 volt, E2 is 2.4 volt. Okay, whereas internal resistance is 2 ohm and R2 is 4 ohm. Okay, so now they are connected in parallel. So let us take a parallel formula for that. And now mainly what are we supposed to calculate here? We are supposed to calculate current and the potential drop across the resistor. So you can just, yeah, you are supposed to find out what is I and what's the potential drop. Okay, so now first let us find the what is the equivalent EMF in parallel and equivalent internal resistance in parallel. Okay, so we have a formula. Equivalent EMF can be taken as E2 R1 plus E1 R2 divided by R1 plus R2. Okay, so now let me just substitute. So E2 R1, so 2.4 times 2 plus E1 R2, so 1.6 into 4 divided by R1 plus R2, 4 plus 2 plus 4. So you can write it as 4.8 plus, okay, so you will get, so 11.2 divided by 6. Okay, so 11.2 divided by 6 can be taken as yeah, okay, something around 1.8 volt you will get it. Okay, so equivalent EMF you found it. Similarly, let us find out what is the internal resistance, equivalent internal resistance. So let me take a formula R1 R2 by R1 plus R2. So R1 into R2 is 2 into 4 by 2 plus 4. So you will get 8 by 6. Okay, 2 4 is 8, 2 3 is 6. So how much will you get? 4 by 3, something around, yeah, 1.3 ohm you will get it. Okay, so equivalent EMF as 1.8 and internal resistance as 1.3 you are getting. Now directly you can substitute this in the current formula. So we have a current formula with respect to internal resistance and equivalent EMF, that is E, okay, divided by R plus internal resistance equivalent EMF. So just take it, equivalent EMF is 1.8. So divided by R is how much? The total resistance is given here, that's 10 ohm, plus the internal resistance is 1.3. So you will get 1.8 divided by 10 plus yeah, 1.3 is 11.3. So you will get something around 1.8 divided by 11.3, 0.159 ampere. Okay, so you're getting I as 0.159 ampere, whereas what is the value of voltage over here? Directly take a Ohm's law formula, V equals R times I. So the value of R is 10 times I is 0.159. So 10 into 0.159 will be 1.59 volt. Okay, so these are the final answer. So even you can round it off over here, 0.159 can be taken as 1.6 also, or 1.6 volt also can be taken. This numerical can be done in a different method as well, like using the Kirchhoff's voltage law connection, but I think this is quite easier compared to the previous method. Okay, so now let us move to the next question. Okay, so this is the last question. Okay, so here we have a two long parallel straight conductor. Yes, again, this is one of the very simple question. Okay, so yes, so we are taking a two conductors and we'll name the conductor as A and conductor B, where the conductors are separated by 1 meter apart distance. Okay, so the distance between a conductor is, between A and B is 1 meter. Okay, so now this conductor is carrying a current of 1 ampere. So let me label it I1 as 1 ampere, and the other conductor is carrying the current I2 as how much? 2 ampere. Okay, and they both are running in the same direction. You can observe that they are in the same direction. Okay, now let us place one more conductor in between A and B. Okay, and this conductor is labeled as C. Okay, so this conductor is carrying the current of 1.5 ampere but in the opposite direction. So I will take this as I3. The value of I3 is how much? 1.5 ampere. Now what is the force per unit length on C? We should see. Okay, so what is the force per unit length on C? Since C is in between, in the mid of A and B, so what we can do here is, so let me first, we know the force per unit length formula, that's force per unit length formula is mu naught by 2 pi I1, I2 by the distance between the two conductors. So now to find out what is the force acting on C, first let us find out what is the force acting on C due to A. Okay, then we will find out what is the force acting on C due to B. Okay, so let me take that as force on C due to A. I'll write it as FCA per unit length equals mu naught by 2 pi. You can write this as it is. Now it is with respect to C and A, right? So instead of taking I1 and I2, let us take it as I1 into I3 over here. I1, I3 and the distance between them. If this is 1 meter, what is the distance between A and C? It is 0.5 meters. Okay, so you can just take 0.5 here. Now, what's the value of mu naught? Mu naught is 4 pi into 10 power minus 7 divided by 2 pi. Okay, so the value of I1 is 1 and the value of I3 is, 1.5. Okay, it's given over here, divided by 0.5. You can cancel 2 pi here too. Okay, and then yeah, 1.5 divided by 0.5 can be taken as 0.3, right? Okay, and then 3 into 2 is 6 into 10 power minus 7. It's a force per unit length. So let me take the assign it as Newton per meter. Okay, so similarly, let us solve what is the force acting on C due to B now. Okay, so you can just take the similar method. Force acting on C due to B can be written as 4 pi, yeah, sorry. Okay, mu naught by 2 pi. So it is C is I3 and yeah, and then B is I2. So let me take it as I2 into I3 and the distance between them will take it as 0.5. Okay, so now we'll substitute it. So mu naught is 4 pi into 10 power minus 7 divided by 2 pi. So the value of I2 is 2 and then value of I3 is 1.5 divided by 0.5. Okay, so you can cancel here 0.5 one time, 0.5 three times. Okay, and then 2 pi